Hi and welcome. My name is Rafael Taubinger and I'm going to give you a quick overview on the newly released IAR Embedded Workbench version 9.10. The new IAR Embedded Workbench for ARM version 9.10 adds support for 64-bit ARM cores including ARM Cortex A35, Cortex A53 and finally Cortex A55. In this short video, you will get a chance to explore the features of the latest release, including the following highlights. So, of course, support for 64-bit, the AArch64 and 32-bit AArch32 execution modes, including the ILP32 and LP64 data models that are also needed. And we have the high-performance CSPI 64-bit instruction set debugging simulator, so that's completely new. And our I-jet debug probes now, of course, also support 64-bit debugging. And there are plenty of new devices for the 32-bit world, but of course we are talking here about 64-bit. And I can mention, for example, the NXP IMX8M families. That means IMX8M Quad, Nano, and also, of course, IMX8M Mini that are now fully supported. And we also have the TI families, the AM65x and the AM64x available in the ID. So now I'm going to move to the practical demo. So I want to show you how this all works together.
So as you can see, I have here the IAR Embedded Workbench for ARM open. When you open the IDE, the first window that appears is the Information Center. And from here you can get access to some examples, documentation, and some additional information about integration and so on. So the best way to get started here is either use a ready example or you can even create a new project, a C or C++ project. To make it a bit easier and straightforward, here I already have an example. It's mainly a simple main application that will print some information on the terminal I/O. And what I want to show you here on version 9.10, we added actually, once you start, you probably are aware about that, you need to always start by selecting either a core or a device. And if you look on the list of cores now, we have here Cortex A35, A53 and A55 added here and supported. That gets enabled when you have the right license. And once I select the core or the device, and as I mentioned, we have a few devices that we added here with 64-bit. If we look here on the IMX8 list, you can see all the variations of A53s and M4, M7s being supported. If we look here on TI, you can also see the AM65x being listed here. So that's mainly on the device side. But very important, you always have the option to run an application in 32 or 64-bit mode, and that's adjusted here. You can, of course, select if the data model to be used should be ILP32 or LP64. That's still up to you to decide. So you can easily configure that. And integrated, doesn't matter if you're using 32 or 64-bit. If you want, you can add cstat for static analysis. That's also available for 64-bit. And the same here, if we look on the checks, you will see that we have Misera, 30C, standard checks, everything available. You can just improve code quality here. For runtime checking, divisions by zero, overflows, that can all be triggered here. You just need to enable it. The compiler, very powerful. The technology, all up to you. If you want to use higher optimizations with balanced size, speed optimizations, that's all up to you. You can still configure that on your side. And very important, when you have a device selected, the IDE will already suggest some linker file and for the debugger some device description file. But it's all up to you how you want to run your application. Is it on a DDR or is it on the internal RAM? That's all configurable. And for example, here I have the reset address, the memory regions being defined here, and also stack and heap. If I'm using that, you can easily configure it. From the debugger side, as I mentioned, the simulator also supports 64-bit instructions, but you can, of course, also select some different driver. If you work with I-jet, you can also do debugging on hardware with 64-bit, very easy and straightforward to use. On the I-jet settings, you mainly have the interface. If you are going to use multi-core, that's actually where you can do some additional settings to let the device know how you want to interact with it and the probe to understand it. So this is from the settings. Once the settings are confirmed, I can mainly build my project. Just a few files, so it's straightforward. If I have a big project, I can enable parallel build, so more files will be built at once, depending on how many cores you have on your PC or desktop. But from here, no warnings. I can just start my debug session, and I'm using the simulator. So once I enter into debug mode, I have full control here. It will land at main. And you can, of course, do step by step, either in the disassembly or if you want in the C level. So that's really straightforward. You can see here the 64-bit instruction being displayed in the disassembly. You have all information that you can extract here under view. I mean, starting from registers, memory. If you want to print some information, that's the case here. So I can show you, if you open the register window, you will be able to display all the registers. Some of them can even be manipulated. And if you want to look into the memory, you can, for example, just type a symbol that you know exists, main, for example. It will point you to the address where main is located. Very easy. You can have access to all the variables. You can look at the stack. If you have more cores, that will also be available. If the core is generating any fault exception, you will also be able to dig into it. In this specific case, I'm mainly printing some information on terminal I/O, so I will just close the other windows so we have more space here to display what we want. And I can, of course, set breakpoints at any point. If I run the application, it can stop here. This breakpoint can be turned into a complex breakpoint where you put a condition if a variable has a specific value or higher. That's also a possibility. But if I leave this application running for now here, it will print some information for me. And for your curiosity, I'm mainly printing here actually almond. That's of course some of the fun part of the demo here, but you can do anything on this application. It's up to you. So as you can see, very easy to use. I mean, the way to work with 64-bit cores, you can select the various cores that are supported. We also support specific devices, and that makes it, of course, way easier for you. And finally, you have full control. You can work in a very good way here from the IAR Embedded Workbench version 9.10.
Good. By supporting leading-edge designs needing the performance from 64-bit ARM cores, IAR Systems now enables its customers to make use of the toolchain Leading's optimization technology, also now for 64-bit devices. In addition, the integrated code analysis tools that you might be aware, of course, help you to ensure code quality, and it's fully available. So, are you looking for an easy migration from 32-bit to 64-bit architectures, or maybe you have a mix of 32 and 64-bit? So that's the way to go if you want to achieve maximum performance and energy efficiency. So with IAR Embedded Workbench version 9.10, you can have, of course, 64-bit support if you have the right license. So please just talk to your local sales contact, or maybe you have a direct contact with the FAE. So they will, of course, help you with more information. And finally, please subscribe to our channel and make sure to watch all the videos we have, and there will be more videos coming. So the next videos will be about getting started with the most popular IMX8 boards that are available in the market. Thank you so much, and I hope you enjoyed this video.